In this video, we're going to go ahead and cover section 3.2, logarithmic functions and their graphs. Just to give a little bit of background information, this is the inverse of the unit we just saw, which was our exponential functions. So a lot of the stuff you're going to see is directly related to those exponentials. Okay, let's go ahead and look at the definition here. We have that for x and a greater than 0 and a not equal to 1, okay, the function y equals log of base a of x is true if and only if that x is equal to a to the power of y. And I kind of color coordinate a little bit here just so you can kind of see that whatever's in our exponential equation here, or function if we're graphing it, is also in the log function. So the way I used to do it with my algebra 2 is I would say if you want to go from one version to the other, all you have to do is always start with the base, okay? So we start with the base, we go around to the other side and around to the other side. So if I start with A, then I go around to Y, well, there's my power, okay? Then back around to the X, is equal to x. And you can see that that's exactly what I have here. You know, it's written the other way, but that's the same deal. Okay, same thing here. You start with the base, but since we're going to go backwards to a log, we have to write the log, right? So log base a. We go around to the x, so x is next. Back around to the y is equal to y. And again, it's the same thing we have here, just written backwards. Okay, so I mean, that's basically the same thing. So that's one way to quickly rewrite these, okay? And then it tells us that you can read it like so. This would be f of x is equal to log base a of x. So log base a of x. And this is our logarithmic function with a base of a. Let's go ahead and look at some really quick examples. These are going to be, we're going to do them by hand, and we're going to check maybe one or two with a calculator just so you can see how to use a calculator with these. By hand, if you can only do that by hand if the relationship with the exponentials is an easy one. So what I mean by that is, for example, this one, okay, if I wanted to solve for x equals 1, I'm going to plug that 1 into here first. Okay, so you would have, and I'm going to change that to a y just for the sake of trying to match it up with what I had up here. Okay, so we would have y equals log base 6 of 1, because you're plugging in 1 into the x, okay? And then I would rewrite this as an exponential. So we start with the base. Here, let me kind of show my arrows here. We start with the base, so 6 to the power of y is equal to 1. And based on that equation that I just made, oh, sorry about that. Let me focus that a bit. Based on this equation, the only thing that's going to give me a 1, if it's raised to the power, is going to be 0, because 6 to the 0 power is equal to 1, which means that in this first example, okay, this function is going to be equal to, I'll put a comma because I'm out of space, f of x would be equal to 0 when x equals 1. So if you were graphing it, you would put the point 1, 0. Okay, so I'm going to go a little bit faster on the next ones just so you can kind of see. Now, then I'll show you how, or you know what, I can show you now if you want with the calculator how this would work. So if we go back to this function here, okay, if you can either graph it or you can just plug in the x straight off the bat. So let's go ahead and just plug in the x. How do we get that log function? Okay, so here what you're going to do is you're going to go to your functions. And for this one, you probably do want to use the Desmos, because the other one, I don't think you can change the bases. Okay, these have different bases. So you want to use the one that does have a base. You're going to pick this one, the one that has a base of a, because that one lets you choose the base, okay? Our base is base 6, so there's my 6, and then the x was just 1, and you can see the answer is just 0, which is exactly what we got, okay? All right, moving on to the next one. So we're going to do the same thing. I'm going to go a little bit faster on this one. So now I'm looking at log base 5 of x, but x is 1 over 25, so we have y equals log base 5 of 1 over 125, okay? And if I rewrite that, let me use a darker color for the rewrite. If I rewrite this, it's going to be 5 to the y is equal to all this. So 5 to the power of y is equal to 1 over 120, 125, not 123. Okay. I know, then again, this is past knowledge, that 5 to the third power is 125. But since it's flipped, I'm going to have to change that to a negative. So in this case, my y is going to be 5 to the negative third power. Okay. Equals 1 over 125. And you can check that if you want. So my answer for this one, I'm out of space here. I'm going to put it on the other side. My answer for letter B is going to be f of x equals negative 3. And again, that just means that when x is equal to this tiny number here, okay, my f of x equals negative 3. And we can check it also if you want. So let's go ahead and check that. So I'm going to go back to the one I have. Oh, I don't know why I put an x there. That's an accident. All right. So I'm going to go ahead and change my base. See if I can change that. Just redo it. So functions, okay. You want to go to your miscellaneous tab, and then the one with the base, log, and the base was 5. And here we had 1 divided by 125. And there you have it, negative 3. For these, you can use the calculator, but make sure that you do show your work, this little rewrite right here. So I know that you know what you're doing, okay? I'm going to go through the last ones pretty quickly just for the sake of time. So for this one, we're going to start with our base of 7. So we're going to go 7 to the power of whatever this is equal to x. So 7 to the power of y equals, and x is just 343 in this one. And that one, if you know your powers, I know that 7 times 7 times 7 is 343. So that means that f of x equals 3. In other words, 7 to the power of 3 is 343. Okay. Last but not least, this one. So this one doesn't have a base, and I kind of did that on purpose. I added something underneath it. If it does not have a base, this is what we do. We make it a base 10. Okay. So base 10, let me move up just a little bit here. The log of base 10 is the common logarithmic function. So basically, if we don't have anything there, we automatically assume it's base 10, or we can just write log. So these two things, this one and this one, are the same thing, okay? So in this case, if we're going to do it by hand, you might want to put the 10 so you know what power we're using. So this would be base 10, because that's the base that we have here that's imaginary, but it's actually there, to the power of y, or f of x, okay, is equal to 2, okay? And in this case, it looks like we don't really have anything that's raised to the power of a number that's equal to 2. So this one's going to give us an error. So, and just to double check, because we can check it if you want, let's go ahead and type it out. So we have log, let's do the base 10 so we can see it in action here. So we have log of base 10, okay, and then our x is 2. Oh, actually, we do have a number. But it's something that's okay. So let me rephrase that. Not that it's an error, but it's something that we can't really calculate in our heads, if that makes any sense. So in this case, we did actually have to use the calculator, okay, because this one is not something that we can just get from a power, unless you're like a super genius or something. Okay, so it's approximately 0.301. So in this case, I can just go straight into log base 10 of 2. So I'm rewriting it like this because I specifically used the calculator for this one. Is about 0.301. I'll box up this one. Okay. So in this case, this one again was not an error. It's just something that we can't really calculate. We can't calculate it in our head anyway. At least I can't. Last example, and then we're going to move on. We have letter E. So it's another, and I put it underneath because I wanted to put that box there first. So we have f of x equals log x for x equals -2. This one again, we have a base of 10. So if you want to rewrite it, y equals log base 10 of -2. Okay. And if we rewrite this as an exponential, we always want to try that first, 10 to the y equals -2. Okay. And this one I'm pretty sure is going to give us an error because we don't have any power that's going to give us a negative number like that. Remember that the negative exponents will flip this for us, but it doesn't make it negative. It still makes it a positive number. Okay, so again, if we want to check, we can check that here. Instead of 2, it's going to be -2. So -2, and there we go. This one is undefined. Okay, so another reason that this is undefined is because if we were to graph it, which we're going to show in just a bit how to do, this one only exists on the positive side of x. So just like really, really quickly, this is totally extra. This graph looks kind of like that. So you can see that the domain for this one is going to be 0 to infinity, and -2 is not in that domain. So that's why this one's not defined there. Okay. All right, so let's move on. I believe I think we're going to graph soon. Oh, no, we have a few properties actually first. And then we might do the graphing in a separate video. Just get all the solving stuff out of the way. So here we have some properties. We go ahead and copy these down first. And they're just basic properties. So the first one says that log base a of 1 is equal to 0. And again, that follows what we did in one of those examples where if you start with your base, okay, you start with your base, you go around, a to the power of 0 is equal to 1. So that's where this one's coming from. This one is a little interesting because it's basically what happens is you do the same thing. You start with your base, you go around to the over here, and then back around. So a to the first power is equal to a. So basically, it's the same thing. What some people will notice is they'll say, well, if the bases are the same here, you can kind of just get rid of them, right? We don't want to say we cancel them because that's not exactly the right word, but you can think of it as far as like they're gonna neutralize each other out. So that's gonna be gone, but you always have that imaginary one here. So basically you're left with whatever, whatever this term was to begin with. Okay, in this case. Here we have that's kind of that same concept. We have the inverse property. So if we have our bases like so, this is this right here. So a to the power of all of this is going to give us x. This one's a little bit tricky, so take a look at it a little bit more when you have some time, see if you can figure out the logistics behind it. I'm not going to give you this one entirely. And the last one is basically if we have two logs, okay, same bases, and then, all this is the same. So you have this part the same and you have this part the same. Well, then those two have to be the same. And that's all that's the same. This is the one-to-one property that we saw also in our exponential ones. Okay. All right, so let's go ahead and use these properties to solve some quick examples. This is example number 2. We have a few parts. We have log base 4 of 1. They want us to simplify. So what I recommend for these is to rewrite them because sometimes when we don't have a variable, it throws us off. So log base 4 of 1 equal to x, because basically x is what we're looking for, okay? Or not, what we're trying to find as far as what this is equal to. And then we can do our rewrite, just like we did before. So that's going to be 4 to the power of x is equal to 1, which should look familiar because this is the very first property we saw up here. Okay, a to the 0 equals 1. So that means in this case, this whole thing is just going to be equal to 0. I'm not going to put x because technically there was no x to begin with. I just used the x to help me get from this point to this point. Okay, so this one's going to be 0. This one, okay, we're going to go ahead and do the same thing. So we're going to rewrite it. So we're going to start with we're going to rewrite it how we have it. I'm sorry, log base square root of 7 of square root of 7 is equal to x. Okay, so now we introduced a variable so we can solve for that variable. We're going to go around and around. So this means the square root of 7 to the power of x is equal to the square root of 7. And the only power that's going to give me the exact same thing is going to be 1. So this is that second property we saw up here where, these two are the same and there's that 1 there, so it has to be equal to 1. Okay. And then letter C, okay, this one's going to follow the third pattern. So all we need to do is kind of look at that pattern and match it this way. So I have, and this is just a really quick reminder because I don't want to be going back and forth. So we know that a log a of x is equal to x, okay? And this goes with log base a of x, okay, that's equal to x. So all we got to do is figure out what this is going to give us, okay? In this case, we can see, let me see. Oh, my bad. We can see that the A is matching up with our 5s, okay? So that our base is 5 and our x is 20. So if all this is going to equal to x, because that's what we're equaling it to, then our answer is just 20. I used to do these when I was in college. Once I saw same bases like this, I would just do that. And that's another quick way to do it. Just be careful because technically they're not canceling, it's just kind of neutralizing each other out. All right, letter D is our last, I'm sorry, second to last example, and then we'll stop this video. We have log base 3 of all this is equal to log base 3 of all this. So this follows the fourth property where if these two are the same, okay, well then these two must be the same. So we're going to take those two items, 2x plus 1 and 4x, and set them equal to each other and solve. And that's it, as easy as that. So, subtract 2x from both sides. 1 equals 2x. In this case, divide by both sides by 2. So x is equal to 1/2. Okay. And last example, I just wanted to do one more of these because they're not that bad and people tend to overthink them. So we have our log and our log on this side. Remember, if there's no base, it's base 10. We don't have to write the 10 down though, at least not in this one because we're not really going to do any kind of little circle rewrite. We're just looking at our parentheses here. So this would be x squared plus 3 is equal to 12. Solve. So x squared is equal to 9. Okay, take the square root of that, and x is going to be equal to positive 3. We don't want to put negative 3, so be careful here because some of you might say, well, it's plus or minus 3, right? And typically that is what we have, but since we're dealing with a logarithm, okay, you got to be careful because sometimes it's only going to be on one side. So until we see the actual graph, we won't really know this one. For the sake of simplicity, we're going to use this one for this example, okay?